Hi everyone. Today we're just doing a quick mini lesson on a pattern of numbers known as Pascal's triangle. And I've got the actual triangle covered up for now because I want you to be paying attention to how the triangle works and not just frantically trying to copy it down. And what I actually will encourage you to do is, maybe copy my first couple of rows, and then once you understand the pattern, try generating some rows on your own rather than just copying them right off the screen. So I'm gonna talk about the pattern first, and then we're gonna talk about how it relates to what you did yesterday and what we're going to be doing, in subsequent class periods. So Pascal's triangle starts with just a number 1 there at the top, and then kind of in a triangular pattern, it's got 2 ones underneath it. So 1 in the first row, 2 ones in the second row, and then here's what the third row looks like. Now, I'm naming those as like this is the first thing you see, this is the second thing you'll see, this is the third thing you'll see. You'll notice these are numbered a little differently over here, and we're going to talk about that in just a minute too. Um, so already we can see the pattern kind of being generated here. You kind of have to know to start with these 3 ones here. And those ones are going to continue along the outside of the triangle all the way down on either side. But all of the other terms come from adding up the 2 numbers above it. So for example, here, 1 plus 1 makes 2, okay? So in this next row, I know I'm going to have a 1 here and I'm going to have a 1 here, but then this term here should be a 3 because 1 plus 2 is 3, and then this term here will also be a 3. So if we look, that's what this next pattern, or that's what this next row is. So why don't you take a second and see if you can generate, I don't know, 2 or 3 more rows of numbers, and then restart the video and check and see that yours lines up with mine. So hopefully you've had a chance to generate those rows. Your next row here should look like this, 1, 4, 6, 4, 1. Again, notice the 1s going all the way down the outside, and then all of these just come from, so 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. Then we've got this here, 1, 5, 10, 10, 5, 1. There's our 6th row. I think that's as many as I have printed, but we could keep going forever, right? So we could do another row down here. This would be a 7, this would be a 21, this would be a 35, and so on, okay? So that's all fine and good. We can keep generating rows like that forever, but if I suddenly needed to know what the 15th row looked like, we would know that it would start with a 1 and a 15, okay? Because you'll notice that the rows always, the second number in always matches which row it is that you're trying to find, okay? Which, by the way, is the reason we call this the 0 row. This is the first row, so that the second row is the one that has the 2, the third row that is the one that has the 3, and so on. But if we're looking for a row that's way far down the list, we wouldn't want to keep generating rows of numbers forever and ever. This can get really large, right? And so that would be sort of the recursive way to come across this. And remember, we've talked about recursive formulas versus explicit formulas. The way this relates to things we've been talking about is these numbers actually correspond to the values we've been finding as combinations. So if we think of the rows, and again, we have to think of this row number as 0. So we start with row 0, then this would be row 1, this would be row 2, this would be row 3, and so on. If you label this as row 0, and then as you're counting the terms, we always count this as term 0. So term 0, term 1, term 2, term 3. What you're going to find is that each one of these numbers can be generated by that combination formula, the NCR, that we've been doing, where N is the row number and R is the term number. Okay, so for example, this 15 right here, this is in row 6. So if I did 6C, and then this would be 0, 1, 2, so 6C2, if I were to calculate that using the method we learned in our calculator, so 6, whoops, let me clear that stuff, 6C2, we should get 15, okay? You can try that with some others. So if you wanted to do, this term here, that would be row 5, so we would do 5, choose 0, 1, 2, 3, 4. So 5, choose 4. And if you did 5, choose 4 in your calculator, it would come out to be 5. Okay? So we can generate any row of Pascal's triangle we want just using combinations. So taking a look at this first example down here, it says generate row 10. We certainly could keep building this thing down to row 10 if we wanted to, but I'm hoping that you won't have to. So I'm going to generate row 10 by doing 10, choose 0. And actually, before I start that, I should probably point this out. We know how row 10 is going to start, right? We know that row 10 is going to start with a 1, and then the second term will be a 10. Okay, we know that that's true. Okay, so this would be like 10, choose 0. This would be 10, choose 1. So my next term I would get by doing 10, choose 2. And I'll calculate that in just a minute. And then we're going to do 10, choose 3, and so on. Okay, all the way down to 10, choose 10. Now that's a lot of button pushing, but it can be done. I want to show you one other thing that's going to make your life a little easier. You will notice that Pascal's triangle has this symmetry going right down the middle. Okay, so in some rows with odd numbers of terms in it, there's only one number there in the center. Rows with even numbers of terms, there's 2, but they're exactly the same. What that symmetry does for you is if we're generating row 10, we're going to reach a point where the numbers start starting over. Okay, we're going to reach a point where all of a sudden the numbers are repeating themselves from ones we already found. So once we reach that point, we can just copy down numbers we've already calculated. Okay, so for example here, 6, choose 2 is going to have the same value as 6, choose 4. Those two things are exactly the same. What you should notice is that 2 and 4 add up to 6. Okay, so anytime you have two terms where their terms add up to whatever row you're in or whatever it is you're choosing from, those two values are going to match. Okay, so that means like 10, choose 2 should eventually line up with 10, choose 8. 10, choose 3 will match up with 10, choose 7. Okay, the numbers that add up to 10 are always going to match. So let's go ahead and start generating some of these. So I'm going to do 10, choose. Now I don't have to do 0 or 1 because I know what those are going to be. So 10, choose 2 would be 45. Okay. I'm just going to hit second enter and just switch this to 10, choose 3. And so that should be 120. My next one would be 10, choose 4. So 10, choose 4 is 210. 10, choose 5. Now this 10, choose 5 should be the center of my row. So 10, choose 5 is 252. Now what should happen because of that symmetry is my next term, which would be 10, choose 6, should be the same as 10, choose 4. Let's check it just to make sure. So 10, choose 6, yep, is 210. And so what that means is I've got 210, and then my next one will be 120, and my next one will be 45, and then I know my row is going to end with a 10 and a 1. So these numbers here, there should be 11 of them because there's always one more than the row number because we're starting with term 0. So there should be 11 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's row 10 of Pascal's triangle. So you should be able to generate any row I ask you for just using combinations, okay? So this is kind of an important thing to know. I would make sure you have this written down someplace. Okay, that's how you generate a row of Pascal's triangle. Okay, what is the third number in row 64? I try really hard on like assessments and stuff to be real specific by what I mean by the third number, but for our purposes, the third number is like the counting number. So like this would be the third number, even though it would be term 2 in that row. This is talking about which one is in the physical third position. Maybe that would have been a better way to ask that question. What's in the third position? So the third position, remember, would actually be term 2 because we're starting at 0, like 0, 1, 2. Now this is not row 64, but I can find that third number by doing 64, choose 2. Okay, and I would write down that this is how you got your answer. We're doing 64, choose 2. And it's 2016. Okay, there's one more thing you need to know about Pascal's triangle today. There's actually a ton of things to know about Pascal's triangle. This is there are so many different patterns and relationships that show up in Pascal's triangle. I'm trying to focus specifically on what you're going to need to do our next lesson, which is binomial expansion. And that uses these rows of Pascal's triangle. So that's why you need to know this first. But the next question says, what is the sum of the entries in row 20? So if we wanted to, we could generate row 20 just like we generated row 10, and then we could add all the numbers up. That doesn't sound like a whole lot of fun to me, but we could do it. Let's see though if there's a pattern that maybe emerges that would make our lives a little easier. So if I add up the numbers in row 0, that would just equal 1. Okay? Sorry, my printer's making noises behind me here. If I add up the numbers in row 1, I get 2. In row 2, I get 4. Sneak that in there. In row 3, I get 8. Row 4, I get 10. Let's see, 14, 15, 16. I should have known that because I know what the pattern is. My next row, if I add those up, that should be 32. My next row is 64. Okay, so let's think about our pattern here. Hopefully many of you caught on to the fact that it's doubling each time, right? The sum doubles each time. So we could just keep doubling down to the 20th row. That's, again, thinking kind of recursively. We don't want to have to keep doing the same thing over and over again. So let's see if we can think of a relationship between this number and the row number. How is this related to this and this related to this? Well, if it's doubling every time, really what we're looking at here is powers of 2. So the sum of the rows is always going to be represented by 2 to some power, okay? Think about 2 to what power makes 1? 2 to what power makes 2? 2 to what power makes 4? 2 to what power makes 8? And what you should be coming up with is 2 to the power of the row number will always give you the sum of the terms in that row. So if I want the sum of the entries in row 20, that would be 2 to the power of 20. Okay, so 2 to the power of 20, I can go ahead and actually figure that out. 2 to the power of 20 is a really big number. 8576. And that definitely beats generating row 20 and then adding up the numbers. So again, just to clarify, this is an important thing to know, that if I want the sum of the terms in any one row, I'm just doing 2 to the power of the row number. Okay, I guess I could have written this as 2 to the power of n because we're using n to represent the row number over here. Okay, so if I want row 4, the sum of the terms in row 4 is 2 to the 4th power, which is 16. Okay, in the 6th row, it's 2 to the power of 6, which is 64. Okay, today in your homework, there are going to be some questions that ask you to investigate some of the relationships in Pascal's triangle, specifically some of the ideas of symmetry, the fact that like the rows always begin and end with 1 and that the second term in always matches the row number. Okay, so you always start with a 1 and then the second term is always the row number. And then from there, the terms are generated by the sum of the terms above it. Or you can generate them using combinations. And this is probably the easier way to go so that you don't have to draw out the triangle every time you're trying to work with Pascal. And then, like I said, next class, we're going to be talking about how these rows interact with the polynomial stuff that we've been talking about, okay? Because there is a relationship there. But you are going to want to be to the point by next class where you can answer a question like this really easily. If I say generate row 10, I mean, you'll have a calculator at your disposal, but you'll want to know that you can generate those using combinations. Okay, I think that's everything I have to say about my friend Pascal. If you're looking for something to do, go search up Pascal's triangle on YouTube and you'll find some really interesting videos about all the different crazy patterns that show up in Pascal. Too many to even name in one place here, but Lots of different ways that these numbers kind of interact and relate to other areas of math. Pascal's triangle is going to come up again in probability. It's going to come up when we do binomials. It's going to come up in lots of different places. So yeah, that's about it for me for today. Like I said, you're going to be kind of investigating this today for homework. You're going to answer a few questions for me, and then we will use this when I see you next time. All right, that's it. Have a great day.